Thank you, Caroline. Hello, everyone. I have this trick I was sharing with another speaker. When you're stressed, just tell everyone you're stressed. So, just so you know, I'm a bit nervous. It's a pleasure to be here. So, I work for a company called Theodo, initially based in Paris, hence the massive accent. I work in the London office, so you can imagine what my accent was 2 years ago when I moved to London. And next week I'm moving to the US, and I really can't figure out how to put on a US accent. That's going to be very funny. So I run, along with a load of colleagues, we've been running it for 2 years in London, the React Native Meetup. So if any of you are London-based and don't know it exists, please join us. It's a really cool event. We are trying to have it every month towards the end of the month. So, the title of this talk is Troubleshooting a Slow App, a Practical Guide to Great React Native Performance. So, just to give you a bit of context, at Theodo we create web and mobile apps for clients using Lean and Agile. We have all sorts of clients. We do backend when they require it. We do front-end. Really depends on what they need. And recently, we've been helping teams create their front-end websites using React, their mobile apps using React Native, sometimes both at the same time. We're doing this on made.com at the moment, and sometimes separately. And in this case, I'm going to talk about the separate approach. So we are talking about Smarkets. Oh, guys, wow. Please challenge if this happens again. Cool. So I'm gonna start the presentation now. Cool. I sense there's a lack of vulnerability between us, so don't hesitate. If there's anything completely obvious like this, just jump in. Thanks. Oh, thanks. So we're talking about Smarkets. Smarkets is an online betting platform. They are mostly known in the UK and expanding internationally. Earlier this year, they contact us. They have this website, so that's a screenshot of the website. It's fairly rich. It has a really nice mobile responsive version, and they have tons of users. They had started late last year moving this website to React Native, which I think many people do, and they were struggling a bit. So they said, okay, MVP, we just wrap our nice responsive website in a web view and ship it to the stores. That worked fine. It was far from great, but it was fine. It was doing the job. So they got in touch with us and were like, okay, can you help us like ship the proper mobile app? So that's when we jumped in. So this is a horse race. It's something that British people enjoy a lot. This one is in Cheltenham. I think it's in March. So that was our first deadline. We joined the team in January. And they say, okay, so right now the WebView is really struggling with when you're betting on a horse, you get live updates from the prices, and it's really, really slowing down. So we want people during that race to be able to bet on the app, a better version of the app. So that was setting our deadline. So we did it. That was that was okay. It was a lot of work, but we put they had so many React components on their web version that we could reuse, so that was very nice. The whole Redux, so they were using Redux, so the whole Redux structure was quite easy to like transfer to React Native. We put it to production, and then we're like, cool, this is paradise. Let's enjoy our lives. And actually, of course, you've probably all been there. You deploy something to production, and then you start feeling the pain. And things don't go exactly as well as you expected. In our case, it was not so much bug issues. It was really the app felt slow in certain use cases. It felt slow, and it was slow, to be honest. So what do you do in that situation? And that's really goes back to the lean principles. I don't know if you've heard of lean manufacturing, lean management. If you haven't, I'm happy to dig into that later with you after my talk. But in the lean approach, in general, you always try to measure your problems. And actually, most articles you're going to read about React Native performance or any web performance, they're usually very long, full of great ideas that we've actually used. And they always end with, but measure your improvements as you do them. So that's why I'm starting with this, because if you read this, at the end, you've probably wasted a few days trying to improve things without measuring the impact you're actually having. So measure things. It allows you to see time wasters, like things you're trying to work on and that actually don't improve anything. And yes, identifying the low-hanging fruits. Like if you measure throughout your app, what is slow, what is fast, what is okay-ish, then you really need to check the slowest and start with the one that seems the easiest to fix. One really important thing to do, because we are not born equal, all born equal, you might have a really cool latest iPhone, but your users probably don't. So measure on something that actually matters. So you need to know your users. If you have any sorts of analytics, measure on that. So what do you measure exactly? So there are loads of things you can measure. So frames per second, quite obvious. Load time, you can measure flame charts. I'm going to dig into that. CPU usage. The one we focused on was janky frames. And we really picked one measure that we tracked throughout our project. So just to give you a quick introduction to what janky frames are. So you have in your React Native application, you have your JavaScript thread where logic is running all the time. And it's trying to push an update to the view of your application every 60th of a second. So you're trying to have 60 frames per second. And every time your JavaScript thread is actually not ready to push something new, you have what you call a janky frame. It's like the view has not been updated. So that's the measure we picked. So we had that measure, the thing we wanted to measure. How did we measure it? So we picked a user journey that we were going to repeat throughout our project to see how we improved actually the user's experience. We used an Android test device, which still hasn't changed, so it's like a Samsung like 2016 something. Mid-end, quite old. So that's a really good idea to have an old phone with your team. You just plug it in your computer, you start the application, follow that journey, and at the same time you run this command, and it will, with com.example is your bundle name, and it will track and gather information about all the frames that are displayed, and at the end it gives you a percentage. So that's an example of the output. So you have, over the frames I've measured, you have like 170 frames that are janky. So there was no update. So that's a number. That's 20%. You print it. Okay. You want to avoid this. So what you have to do is take this chart, print it, or draw it on a whiteboard next to where your team works every day, and update it every day. Because if you don't, if there's one guy staying late who's like, oh, I want to do some cool like engineering things to improve the performance of my app, the next morning someone comes in and maybe will touch a feature you've done and will completely throw it away. And that's super annoying, to say the least. So share it so that it becomes part of the culture of your team. You know that now the focus of your team is on performance and everyone should chip in, or at least not destroy everyone else's work. Then, okay, cool, you have this measurement that you're sharing with everyone. What you want to do next is decide where to start. So I'm not going to go down into loads of code examples. It would be really a rabbit hole. So we found loads of tiny fixes that we really had no idea would come up. And they're always very specific to what you're working on, so that wouldn't be very relevant to all of you. I'm going to share just a few key learnings. So one key learning is that you should beware of usual suspects. Premature, because if you're like, oh yeah, I know it, like when you're doing React, you should use pure components everywhere. So let's take a week and replace all the components that can be replaced by pure components, and let's do it. Actually, you have no idea. So you might spend a week working on something that brings no value to anyone. So really measure it. Don't try to guess what you need to fix. If you think something might be a good idea, just give it a try on one component. Check if it actually impacts performance. If you really don't have a clue, just go to the React Native docs. There's an amazing page that's being updated all the time about React Native performance. It's super, super helpful. But really, like, there's this principle of presumption of innocence. Like, just because you think something is guilty doesn't mean it is. Prove it. So there are plenty of tools. Some of them are listed on the React Native documentation. Some of them are not. We've not used all of them. In particular, we couldn't use the React DevTools profiler, which was released later this year. But we used the Chrome debugger's flame chart in a comparable way. It was super helpful. We used Why Did You Update? Has anyone in this room heard of Why Did You Update? Okay, a few of you. So sorry for this one, but everyone else, check it out. It's a very simple library that allows you to actually check why a component was re-rendered. Okay. So the way you use it, you wrap a component and just one at a time. Don't do it on all your components. Have a very step-by-step approach. You wrap it, and then it's going to log in your console why it updated, and if it updated for the wrong reason, it's going to tell you where to start digging. Helped us a lot. The flame chart allows you to see what's happening more at a component, also at a component level. So it's very interesting to debug, like see exactly what's happening in which layer and which functions are called and how many times. If you're using Firebase for your application, Firebase performance tracking is really nice. You basically say, for all your users in production, you tell them, okay, I want to measure how much this interaction took, how much time it took, and then you can see if actually the struggle you identified on your device is a real-life problem. So quick example of why did you update. So this is the output in your console. So here, so just to remind you, we've wrapped a flat list in a why did you update, and you run the app in debug mode so that you have console output. It's going to flood your console if you pinpointed a good candidate. And here, what you can see is that we have 4 properties that are not equal by reference. So it's an easy fix, because the issue was we were in the render method, we were changing the value, changing the pointer to a value, but the value stayed the same. So React was re-rendering. It was due to a certain user setting somewhere in the state. So really very easy to fix, can actually be spotted by linters, so linters can actually help you ensure the performance of your application stays pretty good. Here, spotting issues with the flame chart. So this is an example of the flame chart, so it's fairly common to use it. If you start using it on, so basically you start recording what's going on in your app, and it records all the calls to functions, so it can go really deep and quite hard to understand. So now, as I said, the React debugger DevTools includes a profiler that does that in a nicer way, but the idea is the same. So in this scenario, what we saw is that there was a timer, that was calling about every second a function that would re-render everything on the page, and so many components were re-rendered every second, and because they didn't need to be rendered, you couldn't even tell by looking at it. You didn't know there was a timer running because most of the things didn't need to be updated, and you're like, this page gets super laggy, but it's impossible to understand why if you don't look at this. And so basically by just saying, okay, you should only update in that scenario, it's sped up the app a lot. Here is another example of the flame using the flame chart. So here we had a map with custom markers on the map. And we wanted that when you click on a marker, you change the style, basically make it bigger, change the color. And because we noticed with this that if you look on the first line, all the custom markers are being re-rendered, and when you were clicking one marker, it took like 200 milliseconds to update. So it was a bit painful. And by noticing this, we're like, okay, obviously only one of them should update. So use should component update, very classic, and then only one of them is rendered, and you win like 160 milliseconds, which is quite helpful. This is probably the one that we enjoyed the most. Like, it's super straightforward. I could have put it even bigger, but it's very, very important. And React Native upgrades can be very painful. I'm sure you've all been through it. But if really in our scenario, we had this very laggy password field. Like when the user would click in it and start inputting things, there was a lag. It was so weird. We spent hours trying to understand why. And it's absolutely not a cause-consequence relationship, but someone was upgrading React Native and noticed that the latest upgrade fixed it. So we were like, what happened? And there was a commit that said, okay, fixing the password field issues. So that was a pretty nice present from Facebook. So if we look at the project overall, like our journey towards better performance on that project, so we started with 38% janky frames. So that's cool. I told you, lean principle, measure what you do, see your impact. But also one super important idea is that you need to have a target. So we're like, okay, we have 38% janky frames on that journey. What does that mean? And we can feel it's bad, but what does that mean? Well, should we aim for 0%? So we did that first round where we used why did you update on big flat lists, things like that, and we got to around 20%, 25% janky frames. So it was cool, but then it sounded like an easy step, and reaching 0% was not going to be doable. So we decided to actually check, okay, how does a super worldwide used application perform? So on that same phone, very important, we checked Instagram, and on my phone it was like 19% janky frames. So we said, okay, from now on, our target is 19%. We want to reach that and stay below it. So we started working on it. We got under 19%. Then, of course, we stopped caring about performance because we were there. That's super nice. So someone introduces a new feature, and then suddenly in your journey, you have a spike of janky frames because you forgot all the good practices you learned the week before. Classic. So then, okay, but because we still were updating our indicator, it popped up, but we could have easily forgotten and not cared at all, and that would have been a pity, really. And then we got back under 19%, which is cool. Other takeaways from that long journey. So I was mentioning they were using Redux in the application. So what we learned is if you put everything in Redux and without even thinking about it, in that case, because it's a live betting app, you have so many updates coming from your WebSocket connection and loads and loads of data stored in the Redux store. It can get super intensive for your device. So use Redux with care, and with reselect, super important, because selectors can get complex for data that doesn't change. So linters, obviously, as I mentioned, if you spot a practice which is don't put arrow functions in your props in your render view, in your render method, well, there is a linting rule for that, so just use it. In that scenario, we haven't had to use bridges to the native world, so it was all JavaScript improvements, which we were not sure were going to be enough. But in most cases, like, start with JavaScript improvements. When you have animations, you have also nice, if you've done animations, you've probably felt the pain of like, your animation is very slow because you're doing it in the JavaScript side. If you're doing other things like sound processing, for instance, don't do it in JavaScript, and you probably can't, so you're going to have to build a bridge between the logic that does the sound processing and your JavaScript logic. And that's a whole different topic. And yeah, so we've reached the end of that short journey. So the wrap up is really like optimizing performance is an engineer's drug, just like that bee. You can like, it's amazing. There are so many opportunities to improve meaningless things, and it's actually hard to spot the ones that really matter. So make sure you often take a step back and ask yourself, okay, am I really making a difference for my users? And it's a team effort, definitely. And that's it. Vielen Dank.